Hello, this is a short video to talk you through the MTT data analysis. There's a number of ways that we go about this. One of these ways is to look at your data prior to normalization. And then the second way is to look at percentage viability. And this video is going to talk to you about the percentage viability and how you do that. So the data set is an example data set, and it contains optical density readings for an MTT assay performed on cells following exposure to microplastics. So let's have a look. So we've got our data set, and quite a lot of this first initial bit will be familiar to you, and then it will get a bit more in depth. Don't be frightened by it. I will highlight which bits you need to change based on what your data set may say. So first of all, I'm just going to read in the data, and I'm just going to call it data. Remember, you can call it whatever you want. And I'm just going to check the names of it. So we have a sample, concentration, and OD50. So let's have a quick look. So you can see for each sample, we've got the concentration and we've got the optical density for our different samples. And first of all, I want you to do, so part A, is I want you to standardize each sample based on the zero concentration. So it's not too different from how you would calculate means using that summarized by. It's slightly different though, we're using the group by and the mutate function here. So just think about what your data is called, and I've highlighted what that data should be changed to. Okay, so I'm just going to call it data standardized. We've called our data data, so it should be data here. I want to group it by sample. We've got sample down here, and basically I want to mutate it and basically have it for each sample base it on our zero concentration. Don't worry too much about what this bit is doing, but essentially you need to change what your data is called here. If you've called it assessment or rainbow, it needs to be that all the way through, and then whatever the data set has as your sample needs to be changed. So just going to run that initially. I'm going to have it standardized. So you can see our concentration 0 then becomes a 1 all the way down. What I then ask you to do is I then want you to summarize the means of these based on the concentrations. I'm not going to do that here, but you know the code from the ANOVA workshops on how to do this. So using that summarize by function, and I want you to group it by concentrations. And then I want you to visualize the data. Remember, it's important to have a look at what your data is showing you. So we're just going to use that ggplot. So I've called it summary data when I've created that summary table. And this is what we've done in the workshops. I want concentration on the x-axis and the mean on the y-axis. I've just added in some information here, some standard errors and some labels. So let's have a look at what that will give us. Okay, so you can see that this is quite non-linear. We've not been dealing with non-linear regression, so this is why we've done these videos for you. But we now want to plot it on a log 10 scale. So if your data is not linear, one of the ways that we can make it become linear is by transforming the data using log 10, or we can proceed with a non-linear regression. So I've just asked you here, it's exactly the same code again, but I'm asking you to scale it on a log 10 scale so you can have a look at that data. And this data looks a bit nicer, and we're going to be using this to make our IC50 predictions. So what do we need to do now? So we now need to fit the model, so our non-linear model, to our data. And here we do require a new package, so the DRC package. I'm just going to check it's available in here. Remember that you will need to install this package before you load this package. Okay, so I've got DRC here, and this deals with dose response curves. The function we're using is DRM, so I'm just going to call it a fitted model to our DIM. Again, this could be something, you could call it dogs, but you then need to make sure you call it dogs down here. We're basically asking it to look at the mean standardized OD 570 as a factor of concentration. We're using that summary data that you have created in part B. Essentially, it is fitting a model to it. So we've done that, and we can see that it's fitting our model up here. Don't worry too much about what that shows. And from that, and what you've been asked to do is you've been asked to extract the IC50. So the IC50 is just the effective dose. We just feed it the model. We ask it what value we want it to create, so 50%, and interval equals none. This is just if we want it just to return the value, so don't worry about this. So the only thing you're changing here is whatever you have called that model that you've created above here needs to be replaced in here. So you can create that as an object, and then you can read it. So you can see down here that it's given us an estimate of 0.4166361. Remember to use the appropriate number of significant figures when reporting your IC50. So we've got our IC50. We now want to produce a figure with our line of best fit through it. So what we want to do is to create a nice smooth curve through our data, which best fits that data, is we essentially need to create some new data. So to do that, we're creating some new data. We're creating a data frame based on our summary data using dollar concentration. So that concentration column for about 200, this could be 300, 400, we'll keep it at 200. You don't need to change anything here. This should be based on your data set. This should be concentration from your data set. It might be conc, so just change those bits if you need to. We'll run it. You can see the length is 200 observations. And now we can move to plot it on ggplot. So as part of that new data, we're going to make some predictions. So remember, we're using that dollar operator to create a new column here called pred, or predictions. And we're going to make a prediction based on our model using our new data. Yeah, so it'll give you for each concentration, and it's gone up all the way up to 200. It will pick each concentration and predict what those values should be. And now we're just going to plot it. So we're plotting that summary data again. We want concentration on the x-axis. We want our mean on the y-axis. Remember, we want it on the log scale here. And we want it the line, so the line through our data points to fit the model. We want that to be based on that model data that we've predicted. Okay, so we're telling that the data we want is from that new data that we created up here. And again, got concentration on the x-axis, and then our predicted values on the y-axis. And we run this, and this gives us a nice plot. Remember, you'll have to change the axis labels, but this gives us, through those concentrations with a log 10 scale, we've produced a nice line through our data. So remember, for the viability part of this assessment, you need a nice figure based on your data set. And then you also need the IC50 calculation as well based on your data set.